lecture today. And then we are going to start to take a look, the coding part. And yesterday, oh, no, I needed to, why I cannot, I need to stop sharing. To share, let me first get to the, I need to bring that up to share. This is, okay. This is the queue. Then I can start. Okay, so let's take a look. So yesterday, what we discussed is the queue that we implemented ourselves using circular array. And today, what we are going to see is we can use Java package queue so that we don't need to implement ourselves. And so this concept is kind of similar like when we discuss stack. So we have our own version of stack, and we also learned the stack class from Java collection. But over here regarding queue, okay, it's also from Java collection. But later on, we are going to see with queue, it's a little bit different versus the collections stack, because stack itself in collection is a class, but queue in Java collection, it's an interface. It's not a class, okay? And because it's an interface, and previously we learned interface abstract class, okay, those kind of concepts. Then we know if it's interface, then you cannot use it to create the instance of the queue, is it? Then the question is, how do we use collection queue, is it? So in Java collection, if we want to use one of the options is you can use linked list, okay? And this linked list is to implement the queue interface. But the linked list is a class, and it is a concrete class. Okay, so you can use a linked list to create the instance, okay? But the instance type previously, like we said, you can also make it to queue, is it? So then let's see, how do we use Java collections queue? So it's pretty straightforward, okay? So here, let's see. What we here do is we create a Q1 instance, and the type we say it's a queue, etc. And also remember, it's always like this case with all of the Java collection. So you can customize it. And in this case, we are going to create an integer queue, okay? But you needed to use the wrapper integer class. It doesn't allow primitive data type. So it got to be some class type. Okay, so we create an integer queue instance, is it? And you initiate use a linked list. So this is allowed, okay? And within the Java collection, the major function for the corresponding queue operation, it's not called enqueue, dequeue, okay? That's just the general kind of operation name we gave the whole like queue class. And over here in Java collection, regarding linked list and the queue, the interface, the method, whenever you want to add, it's add at the back. It's called the add operation. Okay, then you just plug in whatever you want to add. So basically, this is equal to our enqueue that we discussed yesterday. Okay, something. Okay. Okay, so this is regarding enqueue. And then let's see. So for Q, we also interested in getting the front item. Is it getting the front item? And in the Java collection, in Java collection, there are two operations you can do. One is called pick. So this is kind of similar like the stack class. We also have that pick, but that pick is to get the top item. Okay, and here this pick regarding the queue, it's to get the front item. Get the front item. And we also have another one. Another one is called element. So this is also return the front item. Okay. And pick. And pick also return the front item. The front item. Okay, so both are return the front item, and there is some subtle difference between these two. Okay, and for the element method, it returns the front item of the queue. Okay, but when the queue is empty, the front method throws no such element exception. So it throws some exception, and that exception is an unchecked exception. And versus the element method, so it also returns the front item. And for the pick operation. So what is the pick operation? It returns the front item, but it does not throw exception. Okay, so if there is nothing when the queue is empty, it just returns no. Okay, so that's a major difference between these two. Okay, so which one you want to use, then it depends on how you design your program. So let's take a look over here. We said, okay, then we want to take a look at what the front item of our queue is. So you can just call the pick. And the toString is always with majority of the classes. And then next is we call the search function. This search function is kind of similar like what we went over yesterday. Okay, so first let's take a look. So you're going to search some item within the queue. So let's take a look. So for this search operation, we want search item, but this time the queue is the Java collections queue. Okay, and what we did is we want to make a copy this time. And this time we make a copy. What we did is we just get all of the items from this queue. So what we did is this is your queue, is it? And you're going to call this add all function and the linked list. So this class, it has the operation called add all. So you can add whatever the elements in the other collection to the data structure, to the collection that you want to add. So it will basically kind of retrieve all of the item from this queue and add it to this copy, etc. And then we can just use the while loop, etc., to check. So to check before it reaches the empty, they check if you can find the item. If you cannot, you just keep removing, etc. Oh, and for queue, then in the collections queue, it doesn't call DQ, it's called remove, because this remove basically is from the linked list. But what it's going to remove is going to remove from front, okay? So this is like our DQ operation that we learned yesterday, okay? And also one other thing I want to mention before we move out of this function is, generally speaking, when you have the empty check, and the other condition. You have these two conditions together. Normally, we put the empty check first. So you get this before this AND operator. And why we do this? And this we call it short circuit check. Is it? Because you see, this always happens first, because if the queue is already empty, then you cannot get the front item. Is it? So if you do this check, if this check is already false, is it? So if this is false, then this condition, it will not be executed anymore, is it? So the loop will be terminated. So whenever you have this kind of thing, multiple condition want to check together, so make sure which condition you want to put it first, okay? Okay, so that's regarding this search function. And then regarding the search function, so we can call that search method that we just discussed, and to see if we can find the item, okay? So that's regarding how, so what here the point is to see, you can also pass a queue to a method, and then you do something on the queue. And what next is in linked list, there is another function. Basically, when we discuss our own version of queue, we didn't discuss like this method. We didn't implement it, is it? Because that's generally not the major feature, okay, for queue. Because regarding queue and stack, they can only access at ends, not anywhere in the queue. So if you provide this kind of operation, that sounds not that applied to the principle of queue and stack. But over here, because this queue basically is a linked list, the instance itself basically is a linked list. A linked list, it has this method called contain. So you can also do the search with this contain function. So what over here shows is you want to check, okay, if 300 is within the queue, then you can call the contain function, okay? And what next section of code shows is you can do the loop, okay? And over here, the first loop, what we did is for each loop, okay? And because this is a collection, so you can also write as this kind of format. Not the very regular one that we learned for integer I from 0 to I less than size, then I plus plus, not that kind. So over here is like you specify the element, and then you have the colon, and then you have the collection, etc. And it itself will take care of retrieve each item from the collection. But for this kind of for loop, generally speaking, is you use it to do the retrieving, okay? And there is another kind of loop, we call it for each loop. Okay, the for each loop comes starting from Java 8. Okay, and this for each, basically the for each, if you take a close look, you will find it is a method, this for each. And over here, and I'm not sure if you still remember what we call of this. So you have something, etc. So it looks like some variable. And then you have the arrow, and then you have the brackets, and you do something. And do you still remember what do we call this? Basically, anyone still remember? And basically what here we plugged in is what? What here is the lambda expression, etc. So that's what we previously learned. So it's quite, you can see it's quite convenient, isn't it? Then you just get each of the element from the queue, is it? And let it do something. So this for each method, you can also use it, okay, to do the iteration. And what over next to discuss is we can also do the looping, do iterating using the iterator, okay? And the iterator later on, we are going to discuss in detail. So here you just get a glimpse, okay? So the iterator basically it's some pointer that you can use it to find the location of the item within a collection of the items and one by one. Over here, so if you want to use it, the very first thing you need to do it, you need to call the iterator method and you get the iterator. Okay, and after you get, so basically over here, it will start from the very beginning, okay? And then you keep calling the iterators has next, and then call its next to get the next item, okay? So this is the other method you can also use to do the looping. And the other one is you can also call the for each remaining method with the iterator, okay, and to loop through of the items. So, but regarding these two iterator later on in our chapters, we are going to discuss in detail. So this example shows how we use Q, okay, from the Java collection. So not our own version of Q. And this Q is so basically when it's an interface, and when you really use it, basically you create it as an instance of linked list. As if a linked list is a concrete class, so you can use it to create a Q instance, Q object, and then you can do something on it. And so here, what we utilize is to utilize the linked list part of the feature that support Q, etc. So you add at back. So we add at back, and we remove from the front. We then remove. So we DQ, so here basically it's a DQ, we remove from front. And you can also do, you can also get the front item, okay, from this queue. So basically you use these three major operations from linked list, and but you treat it as a queue. So that's the major concept here. And okay, resume the recording. And then next, let's take a look. Why I cannot share? Okay, next let's take a look at the Java collection regarding queue and linked list. And what over here we saw is from Java 8. Okay, so it's kind of new version, Java 8. And like I just explained, is it within the, so this is from the official Java document website. And for this, for the queue, like over here, it's an interface, is it? And this queue, it will support different kind of queue, is it? So it's a generic one. So next section, we will learn generic, okay? And so it's an interface, is it? Interface. And the implementation classes, is it? So here it lists. So linked list is one of the implementation class. I needed to go back to the linked list again. So I need first to turn on that. Okay, and then let's share this. Okay, then this is regarding that linked list that we just discussed. So for the linked list, then you can see it's a class. Okay, it's a class. And so for this documentation, the official documentation, and if you take a look, you will find like this linked list, is a linked list, and it implements the list and the DAC interface. Okay, and over here it also shows, is it, for the linked list, it's all implemented interface. It shows it's the queue, is it, interface queue. So that's why we can use this linked list to create instance for our purpose of the queue. And then let's take a quick look of this linked list operation. Is it the linked list? We just said the add operation. Is it? And what it does is, see, it says you add at the end of the list. So it serves the purpose of in queue. Okay. And then let's take a look. The element method. The element method says retrieve the front item of the list. So it does serve the purpose of the front operation of queue. So that's why we say, oh yeah, we can use this. And that's the regarding the element. And we also learned the pick. So pick, it's the same thing, it's retrieve the front of the list item. So it does serve the purpose of the front item, to get to the front item. And there are also other operations, is it, like the pull. So how do you remove, is it, the front item? And in our queue, when we discuss, we call it DQ. And in our example, as we discussed the remove, and here you can see, you can also call pull, okay? So because pull does, it's not just remove the front item, it also retrieve, okay? So if you want to do both operation, both retrieve and remove, then you can also call pull, okay? So that's regarding the remove. So the DQ, is it? And in our code, we use the remove operation, is it? So what remove does is it retrieve and remove the top, the front of the list, is it? So it removes the front item. So basically over here, what you can see is over here, we use the linked list from the collection to achieve the application of the queue. And what next? Let's go back to take a look at the queue interface. Okay, so for the official documentation for queue, is it that interface? So over here says the summary of the queue method. Is it summary? And it says whenever you want to do add, is it, you can call. So whenever we want to enqueue, you can call add operation. That's also demonstrated in our example, is it? And there is another option you can use. You can also use offer, okay, offer operation. And then whenever you want to DQ, is it, from the front, you can call remove operation, okay? And there is another one we just also saw in linked list. It's called pull. That you can also do it, is it? And we also discussed to retrieve the front item. So you can either call element or you can call pick, is it? And the major difference in this table, it also shows the major difference, is it? So for this set of the operation that majorly we use, it will throw exception, okay? For this set of operation, it doesn't throw exception, is it? Because they all return something, is it? So return something, then it can return no, is it? If it's already empty, is it? Or some other scenario. So that's why it says return some special value, okay? Or if the special value doesn't exist, then it can return no. So that's a major difference. So depends on how you want to design your program. You can choose either set. But majorly, this equivalent to our enqueue for add and offer, okay, for remove and pull, it's equivalent to what we discussed yesterday, the DQ, okay? And for element and peak, it's equivalent to what we yesterday discussed, the front. So those are the major operations you can use in queue from the collection library. And so that's the discussion about the collection library and how to make use of them. And it's quite helpful. And what's the next part of our today's discussion is we are going to go over a little bit of a comprehensive example, okay? Example. And this time, what we are going to discuss is to do some simulation. So simulation of checkout lane. Okay, so how do we do that? Okay, so let's first, I'm going to share the screen. Okay, why it's changing like this? I'm not sure why it's changing like this. Kind of very. So what over here, we are going to discuss an example to simulate checkout lane, because we said for queue, one of a very useful application is to simulate some kind of like the lane, the checkout line, is it? So let's see, how do we do some kind of simulation? So what this program will achieve is it will simulate servicing customers in checkout lanes. Okay, so because this is a simulation, is it? So we are going to randomly generation the customer arrival and the expected service time for each of the customer. So we're going to see how do we do this kind of simulation, okay? And we also do opening and closing lanes as needed, is it? Because if there are some opening cache, so if there's some, you have enough cashier, then you can open a new lane, is it? And if the lane is already full, then you're going to close it, won't take any new customer. So that's the concept here. And after our simulation ends, we need to collect some simulation results. Is it? So what over here we are going to collect is total customer serviced, and the maximum minutes spent in line, okay, and the average time spent in line. So we want to collect those kind of information. And the design constraint is you needed to use queue to do the simulation, okay. So that's, let's double check, okay. That's the general idea about this simulation. And then let's see the details about the requirements, okay. So the first is regarding time. So what kind of time we need to simulate? So we need to simulate service time. And we also needed to consider how long it's already running for our simulation. So that's the time we needed to consider. And what's next is how are we going to do the simulation? Is it? So the steps in simulation. So what we are going to simulate is we are going to use a loop. And that loop will be based on how long you want to simulate. is it? And then you're going to count off the minutes of the simulation. And for each of the minute, what we are going to do is we are going to randomly determine if there is a customer arrival. So how are we going to do that in code? We will see, is it? Then we will see if there is a customer arriving, then what should we do? Is it, is the lane full? If the lane full, then we cannot add. Is it? Otherwise, you randomly generate service time for the customer. Okay, and then we place the customer in the first available lane. Okay, and if the lane is already full, then you can open a new lane. So that's the information there. And what's next is the steps in simulation, etc. And then you are going to add that 1 minute because we simulate count off every single minute. So we are going to provide that 1 minute of the service to the customer of the front of the customer. And then we need to determine if each lane, whether the customer has finished the checkout, etc. And if the customer finishes checkout, then you need to remove the customer from the lane, etc. And if lane is empty, then you also close it, okay? And when the simulation finishes, then we need to finish service of the remaining customer in all of the lanes. And that's the general steps in our simulation. So we also need to collect the output for our simulation. So what the output we need to collect is for every single minute, what we need to do is we need to know, okay, at this point, where we are, is it? If the lane is full, is it? And if the lane is open or closed, is it? And the status contents of each lane is at the end of each minute. And at the end of simulation, we need to collect the report. Is it? To collect report is total customer service, maximum minutes spent in line, is it? And average time spent for the customer. So those are the general requirement about the program. And then next, let's continue our discussion is about the simulation, because we are going to simulate, so we need to provide some simulation parameters. Over here, you want to provide totally how many lanes you want to simulate. And each lane, the number of customers, is it? And the number of minutes you want to simulate, 60 minutes or 2 hours or a day, something, is it? And the minimum service time and the maximum service time, the number of customers expected per hour, is it? The arrival rate of the customer, is it? So those information. And then how do we solve the problem? Is it? So this problem, a little bit of comprehensive, is it? So we need to have the customer, is it? Designed in certain structure. So in our case, you will see it's designed as a class, is it? And so you need what kind of information? You need a class, customer ID, customer service time, and when customer arrival, is then the output function for the customer, okay? So that's one data, that's one kind of data that we need to define. And we also needed to define the lane, is it? And the lane in this case is perfectly matched, is a queue data structure, is it? Because you have customer coming in at the back and customer moving out from front. So perfectly match if we use queue. And because there is not a single queue, there are a number of lanes. Is it a group of lanes? So in this case, we can use an array of queue, is it, to do the simulation. And we also need the simulation parameters and the statistics that we want to collect. Is it? So those are the data and it's their type. We need to be aware. And some other type of class is it, and for the, because we are going to do simulations, so we need some random random type of data to do the thing. So we need some random class to take care of the random data generation. Okay, and so The main functions of what we are going to see is we first need to collect some user information, the parameters. So we are going to have that function, okay? And we're also going to count off for every single minute. Because every single minute, what we need to do is we need to process, we need to deal with when customer arrive, what should we do, is it? And we also need to serve the front of the customer and display some information regarding of the lane, is it? And after you loop through of your simulation, you need to finish your simulation of the remaining customer in the lane. And after that, then you can report the collection of the information about your simulation. So that's the general idea about our simulation program, okay? So next, let's take a look the coding part. So the coding part, like what we said, this example. So if you take a look, you will see I have three class. So we have a class regarding customer. So I call it a customer record, okay? So for the customer, you need a customer ID, is it? When customer arrive and how long the customer is going to be served. So those are the instance. And here we didn't define them as private because this is kind of loosely designed because we just do some simulation. Okay, so we didn't consider encapsulation. So we just make of the instance variable accessible within the whole package, okay? So it's not defined as private, so it's available within the whole package. And we do provide overridden toString function to output of the related information. So this is regarding our customer class. And we also have another class called the simulation parameter class. And for this class, we define it as final class. Okay, and here the concept for the final class is we don't want it to be a class that can be used as a super class. So we just want this class to be the final class that no other class can inherit from, is it? So that's why we define it as a final class. And of the instance variables, in this case, just for simulation, so we also make them accessible within this package, okay? So we didn't define them as private, so that it's accessible because it's just for convenience here for our simulation. And then the third one is the major program, is it? And for this major program, what over here we are going to use Q. So that over here we use Java collections Q. Okay, so we are going to import both the linked list and the Q. And then let's see how the flow goes. Okay, so over here we are going to also, because after the end of the simulation, we want to collect totally how many customers and the maximum time for the line. Is it, and the total time, because we want to find out the average time, okay? So we need to collect those. So those are, we set them, we initialize of the information. And then let's see, over here, we define an array of our Q, is it? And the Q type, you can see it's our customer type. Okay, so this Q type is the type, is a customer type that we just defined. And we create 10 Q in this case. So it's an array of Q. And then for each single one of it, we initialize with what? With a linked list instance. Okay, so each of the checkout link, we initiate with an instance of linked list. But here we will treat it as Q because we are only going to use the back and the front. And the first part is we are going to try to get all of the simulation parameters. Is it? We already defined the simulation parameter as a class to collect all of that. And to collect all of this, and you can allow the user input using scanner. But here I just hard-coded for the demonstration, okay, and you can comment out when you run this program to try with the different simulation parameter. And you can see it's quite simple, is it? We directly access all of the instance variable within that class. Because over here, we define them as class level instance, the package level instance variable. So they are not encapsulated. So that's why over here you can access the instance variable directly. So that's regarding get all of the simulation parameter. Okay, so nothing new here. And then what next is we are going to count off every single minute. Is it? We're going to start our simulation minute by minute. Is it? And the very first thing we do is we need to deal with whenever the customer arrives, is it? So let's take a look at that customer arrive function. So for the customer arrive function, we have the simulation parameter we need to know. And over here, we are going to deal with the array of Q, okay, array of Q, and the total number of customer and the current time. Okay, so because for the customer arrive, so each time there is a customer coming in, is it? So that's why here you need to create a customer, okay? And then you also need to determine randomly if the customer arrive or not, is it? So that's why here you just use the mass random method to generate some random number. And then you are going to compare this with the arrival probability to determine if the customer arrive. Okay, if the customer arrive, then you need to determine which queue you're going to put to the customer. Is it? So which queue you're going to put to the customer. So if you find the queue for the customer to go in, is it? Then we need to keep track of the customer information. So over here, we hard-coded the customer ID based on the customer arrivals order, okay? And its arriving time. So over here, we are going to fill the information for the customer. And then you random generate some number for the service time for the customer, is it? And then you hard-coded the customer's service time. And then you're going to in-queue that customer to the specific queue, is it? Because you find the available queue for the first available one. So you're going to based on the first available queue, and then you're going to add it. And I think we kind of get to the time. So today, because this example itself is quite comprehensive, so we cannot just complete it today. So we will continue our discussion tomorrow about this example. And tomorrow we should also be able to finish the complete discussion of Q. And do you have any other questions? Are there any other questions? And I'm also, I don't remember if this example is already available online. Later, I'm going to check. If it's not, I'm going to post it. Any other questions?